So the next problem, total Zedal nitrogen is a measure of A. Total organic nitrogen, B. Total organic and ammonia nitrogen, C. Total ammonia nitrogen, and D. Total inorganic and ammonia nitrogen. So we have studied that Zedal nitrogen is the sum of ammonia plus the total organic or albuminoid. Another name for this organic nitrogen is albuminoid nitrogen. So sum of these two is together known as Zedal nitrogen. So the option is 34B. Next is 1 TCU or 1 true color unit is equivalent to the color produced by A. 1 milligram per liter of chloroplatinate ion, B. 1 milligram per liter of platinum ion, C. 1 milligram per liter of platinum in the form of chloroplatinate ion, and 1 milligram per liter of organochloroplatinate ion. So what we have studied is the standard unit of color, that is 1 TCU is 1 milligram of platinum in the form of chloroplatinate ion that is dissolved in 1 liter of distilled water is known as, then the color produced is known as the 1 true color unit, which is the standard unit of color measurement. Moving on to the next question. If tomato juice is having a pH of 4.1, the hydrogen ion concentration will be. So the pH is here given as 4.1. So pH can otherwise be written as log 1 by H plus ion concentration is equal to 4.1. Now rearranging, we can write H plus ion concentration is equal to 10 raised to minus 4.1. That is, if you are bringing this H plus to the top, then it will be negative log H plus is equal to 4.1. That is, if I am writing it here, we can write it as log of negative log of H plus is equal to 4.1. If you are bringing H to the top, then it is H plus raised to minus 1. This minus 1 we take it outside, that is minus log H plus is equal to 4.1. Log is to the base 10, so concentration of H plus will be 10 raised to minus 4.1. Now, so finding this value, we get the answer as 7.94 into 10 raised to minus 5 moles per liter. On substituting this, we get the answer as this. Now the next question. Match list 1 and list 2 and select the correct answer using the codes given below the list. So list 1, A, that is release valve, B, check valve, gate valve, and pilot valve. So first one is the release valve. This release valve, the main purpose of the release valve is to release the pressure in places in the pipes where the pressure has increased considerably. Then we just open the release valve to release off the excess pressure in the pipes. So release valve is mainly deals with reducing the high inlet pressure to lower the outlet pressure, that is to relieve the excess pressure. Next is the check valve. This check valve is provided to limit the flow of water in a single direction. That is, by using a check valve, it will allow the flow of water only in one direction. Next is the gate valve, which is used for stopping the flow of water in a pipeline. We use gate valve, and pilot valve is used to remove the air from the pipeline. So the correct answer is option D. Now the next question. A synthetic sample of water is prepared by adding 100 milligram kaolinite, a clay mineral, 200 milligram glucose, 168 milligram NaCl, 120 milligram magnesium sulfate, and 111 milligram of calcium chloride to 1 liter of pure water. Now the concentration of total solids and fixed dissolved solids respectively in the solution in milligram per liter is equal to. So they are asking us to find the total solids as well as the TDS, total solids as well as the fixed dissolved solids in the solution. So the total solids It can be said as the sum of this 100 plus 200 plus 168 plus 120 plus 111. The sum of all these salts is the total solids that is present in the sample, which we get it as 699. Now, fixed and dissolved solids, that is, this total solids, fixed and dissolved solids means that total solids minus the suspended solids, we will get the total or the fixed dissolved solids that is present in the water. So the suspended solids, the particles that remain in suspension are this kaolinite and glucose, which will be found only in the suspended form in water. So from the total solids, if we subtract these two values, we get the fixed dissolved solids as 399, and hence the answer is D, 699 and 399. Then moving on to the next question. A water contains the following dissolved ions: sodium, its concentration; calcium, its concentration is given; magnesium, its concentration; aluminium, HCO3 minus and Cl minus, and the water's pH is given as 7. Then atomic weights of all these is given. Now they are asking us to find the total hardness of the sample in milligram per liter as CaCO3. So the total hardness is can be found out using the formula concentration. Total hardness is equal to calcium concentration into 50 by 20 plus magnesium concentration. How all these values came, we have seen in the earlier problems. So just substitute the calcium and magnesium values here. Calcium it is given as 40 and magnesium it is given as 30. So we get the final answer as 225 milligram per liter as CaCO3. Now in that itself they are asking us to find the non-carbonate hardness of the sample in milligram per liter. So here the carbonate hardness is produced by this bicarbonate ion present. So that can, first if we find out the carbonate hardness, then from total hardness if we subtract the carbonate hardness, we get the non-carbonate hardness. So first of all we have to find the carbonate hardness. So this carbonate hardness is given by concentration of HCO3, that is bicarbonate, into equivalent weight of CaCO3 by equivalent weight of HCO3 minus. Now equivalent weight of CaCO3 we have already found out as 50. The equivalent weight of HCO3 minus, how to find out? That is HCO3 minus. Hydrogen's atomic weight is 1, carbon 12, then oxygen is 3 into 16. That we get it as total is 61. Now that is the molecular weight that we have found out now. Now equivalent weight in this case will be equal to molecular weight, which is 61, divided by the valency. Here see the valency is -1. So 1 is the valency. So again equivalent weight and molecular weight in this case will be the same, 61. That is why here this is 61 is given. So carbonate hardness is equal to concentration of HCO3 in water, which is 190 milligram per liter. This 190 into 50 by 61, you get the answer as 156 milligram per liter of CaCO3. Now we know the total hardness, carbonate hardness. So subtracting these two, we get the answer as 86. So option C is the answer. Now next question. The presence of hardness in excess of permissible limit cause A. Cardiovascular problems, B. Skin discoloration, C. Calcium deficiency, D. Increased laundry expenses. So we have already studied that if it's hard water, then it will lead to increased soap consumption, or the soap does not lather properly in case of hard water, as a result of which the laundry expenses goes up. So the option is 41D. Now the next question, the alkalinity and the hardness of a water sample are 250 milligram per liter and 350 milligram per liter as CaCO3. Then the water has, we are supposed to find out the carbonate hardness and non-carbonate hardness. So the total alkalinity is here, it is given as 250 milligram per liter, and total hardness is here, it is given as 350 milligram per liter. So here we can see that total alkalinity is less than total hardness. So we have studied, when we studied the theory portion, we have studied that the carbonate hardness will be equal to the lesser of these two values. So here the lesser will be the total alkalinity. So the answer will be 250, that is the carbonate hardness. So 250 milligram per liter of carbonate hardness. Now in order to find the non-carbonate hardness, that is equal to total hardness minus the carbonate hardness, which is total hardness is 350 given in the question, minus the carbonate hardness 250, that is equal to 100. So option D is the right answer. This 250 milligram per liter carbonate hardness and 100 milligram per liter non-carbonate hardness. That is what is shown here.